What if I told you that somewhere in the outer reaches of our solar system, one of the most bizarre and terrifying cosmic events in recorded history is happening right now, and nobody knows what it is? It started with a routine observation. On a cold November evening in 2024, astronomers monitoring Uranus from observatories across Earth noticed something impossible. The data didn't make sense. The instruments flagged it as a sensor malfunction. But when they checked again and again across multiple independent facilities, from Hawaii to Chile to the Australian outback, the readings remained consistent. Something was catastrophically wrong with Uranus, and it was happening in real time. The planet was screaming. That's not poetic language. That's the literal translation of what the astrophysicists saw when they analyzed the electromagnetic frequencies never before recorded. The planet's magnetosphere, that invisible shield of charged particles surrounding it, was pulsing with energy spikes so violent, so unprecedented, that Dr. Elena Vasquez, one of the lead researchers coordinating the investigation from NASA's Jet Propulsion Laboratory, used those exact words in her private notes before the data went public. She would later tell colleagues that in her 28 years studying planetary science, she had never felt genuine fear while looking at astronomical data until that night. What made this discovery so unsettling was what it represented. Uranus, the seventh planet from the Sun, is one of the most stable and predictable celestial bodies in our solar system. It has been observed continuously for over 200 years, since its discovery in 1781. Its atmospheric patterns barely change. Its temperature fluctuations are minimal. Its magnetic field, while unusual compared to other gas giants, has remained remarkably consistent throughout the modern era of space observation. Uranus doesn't surprise us. It's the boring planet, the forgettable ice giant that astronomers study almost out of obligation, not fascination. So when the most advanced satellite instruments humanity has ever built detected a catastrophic surge in the planet's radiation belts, an increase in intensity by a factor of 300 in less than 48 hours, the scientific community didn't know whether to feel excitement or dread. The answer turned out to be both. The first team to propose a theory was Dr. James Chen and his colleagues at the Goddard Space Flight Center. They suggested a solar flare or a coronal mass ejection from the Sun might have disrupted Uranus's magnetosphere. But there was a problem. The Sun had been remarkably quiet that week. There were no solar events powerful enough to explain what was happening billions of miles away. The radiation spike on Uranus had no corresponding trigger point. It had simply started without cause, without warning, like someone had flipped a switch in the depths of an alien world. That was when everything changed. A junior researcher named Dr. Amara Okoye, working the night shift at the European Space Agency's observation facility in Darmstadt, Germany, noticed something else. While her colleagues focused on the radiation surge, she was studying the visual data. The actual images captured by space telescopes pointed at Uranus. And there, in the upper layers of the planet's atmosphere, was an anomaly so startling that she actually gasped out loud. Her supervisor later essayed he'd never heard her raise her voice above a whisper in 5 years of working together. The cloud patterns on Uranus were changing, not gradually, as they normally do over the course of weeks or months, but dramatically, violently, in a matter of hours. Massive storm systems were forming and dissipating. Atmospheric layers that should have remained stable were swirling and churning with energy. But the truly disturbing part was the symmetry. The patterns weren't random, they were geometric. Impossibly geometric. It was as if something deep within the planet was generating these weather patterns with mathematical precision. The implications were staggering. Something was happening inside Uranus, something powerful enough to reshape its entire atmosphere from within. The radiation. Emissions weren't coming from the planet's magnetosphere being disturbed by external forces. They were coming from inside. Whatever was occurring within Uranus was violent enough to shake the entire planet to its core. Within hours, the observation data had been classified at the highest levels, not because the scientific community wanted to hide the truth, but because they didn't understand it, and panic was a luxury they couldn't afford. Emergency meetings were convened. Telescopes from around the world were redirected toward the ice giant. Universities canceled classes. Scientists who had been on vacation were called back to their labs. The entire astronomical community mobilized in a way that hadn't happened since the discovery of gravitational waves. But what were they looking for? The leading hypothesis, emerging from this frantic period of investigation, was as terrifying as it was scientifically elegant. Dr. Chen proposed that something massive might be moving inside Uranus. Not a solid object, but perhaps a massive disruption in the planet's internal core. You have to understand what Uranus actually is, unlike Jupiter and Saturn. Uranus isn't a true gas giant. It's an ice giant. Beneath its hydrogen and helium atmosphere lies something far more complex. A dense fluid mixture of water ice, methane ice, and ammonia ice surrounding a rocky core. It's more ocean world than planet, and oceans can be stirred, they can be disturbed. They can convect and swirl with absolutely tremendous force. What if something had awakened in that ocean? The historical record of Uranus observation suddenly became crucial. Scientists began digging through decades of data, looking for any precedent, any warning sign, any hint of what might have triggered this event. That's when Dr. Patricia Oloroso, a researcher at the University of Arizona, made a discovery that sent shockwaves through the scientific community. She found evidence that Uranus's internal heat output had been increasing for the past several years. Slowly at first, barely noticeable, but then accelerating. The data had been there all along. No one had noticed because it was so gradual, so subtle. It had been happening right in front of them, and they had completely missed it. This suggested something unprecedented. Uranus's core was heating up. Not from external solar radiation. That played almost no role in heating the ice giant. Something internal was generating heat at an accelerating rate. And now, whatever internal process had been slowly building for years had suddenly reached a critical threshold. The dam had broken. The pressure had become too great, and Uranus was experiencing a kind of planetary seizure, a violent spasm of its internal systems as they tried to reach a new equilibrium. But the question that haunted every scientist working on this problem remained unanswered. Why now? What had triggered this internal disruption? Planets don't just start heating up from within without a reason. Something had to have caused it. And as the data continued to pour in, the leading theory became increasingly controversial and unsettling. Some researchers began to whisper about the possibility of a collision. Not recent, that would have been observable, but ancient. What if, billions of years ago, when our solar system was still young and chaotic, Uranus had been struck by something massive? We know this happened to Earth. The giant impact hypothesis suggests that our moon was formed when a Mars-sized body collided with the early Earth. Similar impacts likely happened throughout our solar system. What if Uranus had been hit by something so large that it fundamentally altered the planet's internal structure? What if that impact had created a fracture, a weakness, deep within the planet's core? And what if, after 4.5 billion years, that fracture was finally failing? The calculations were horrifying. If something was breaking apart inside Uranus, if massive sections of the planet's interior were collapsing or shifting, the energy released could be equivalent to thousands of years of normal stellar activity compressed into a few years. The radiation we were detecting might be just the beginning. If the internal collapse continued to accelerate, we might be watching the early stages of something catastrophic. We might be witnessing the slow-motion destruction of an entire planet. The conversation shifted to the Voyager 2 mission. This was the only spacecraft humanity had ever sent to Uranus. In 1986, it made a brief flyby of the planet, transmitting. The decision was made to reactivate Voyager 2's instruments and point them at Uranus one final time. The signal would take several hours to reach the spacecraft and return. But when it did, the data it transmitted was unlike anything anyone had expected. Uranus's magnetosphere wasn't just being disrupted, it was being reversed. The planet's entire magnetic field was collapsing and rebuilding in real time. The poles were shifting. In just a few months, what had always been a relatively stable magnetic configuration was completely reorganizing itself. But what made this truly alarming was the temporal acceleration. The changes were happening faster and faster. The rate of change was itself changing. The system was heading toward something, racing toward some kind of climax or critical point. That's when Dr. Chen proposed his most radical theory yet. He published a paper suggesting that what we were observing might be a planetary magnetic reversal, a catastrophic, accelerated version of what happens on Earth roughly every few 100,000 years. But on Earth, a magnetic reversal takes thousands of years to complete. It's gradual enough that life can adapt. What appeared to be happening on Uranus was the opposite, a magnetic reversal happening on a time frame of months. A process that should have taken millennia was compressed into a cosmic instant. The implications for the planet's atmosphere were staggering. The magnetic field acts as a shield against the solar wind, the constant stream of charged particles radiating from the sun. If that shield collapsed and reformed, there would be a window, perhaps a brief window, but a window nonetheless, where the atmosphere would be exposed to direct solar radiation in unprecedented intensity. Some models suggested that Uranus could lose significant portions of its atmosphere during this process. The pressure waves, the radiation storms, the electromagnetic chaos could literally blow away parts of the ice giant's upper layers. We were watching planetary death in slow motion, or perhaps planetary rebirth. No one could say for certain. The public didn't know any of this yet. The space agencies and research institutions coordinated a careful information release, trying to present the facts without causing unnecessary alarm. After all, Uranus was over 3 billion kilometers away. There was no immediate danger to Earth, but the scientific implications were profound. We were witnessing a phenomenon that contradicted our understanding of planetary stability. The models that had been built over decades of observation, the theories that seemed so solid, were all being challenged by this single inexplicable event. And then came the moment when everything shifted again. Dr. Oloye, the same researcher who had noticed the atmospheric changes, was studying the latest images when she noticed something extraordinary. The cloud patterns weren't random. They weren't following the normal fluid dynamics equations that should govern planetary weather. The patterns were responding to each other in ways that suggested a kind of intelligence, a kind of communication. The moment she voiced this hypothesis, she was met with skepticism. But the data was undeniable. The atmospheric patterns were structured in a way that went far beyond what chaotic weather systems should produce. It was as if something within the planet was generating these patterns deliberately, sending messages through the churning atmosphere. The patterns appeared at regular intervals. They seemed to follow mathematical progressions. Some researchers noticed that if you analyzed the electromagnetic emissions alongside the visual patterns, they formed a coherent sequence, a kind of symphony of signals. The question that emerged from this observation was so profound that it changed the entire nature of the investigation. What if something alive was trying to communicate from inside Uranus? The idea seemed absurd. Life on Uranus? The planet is cold, hostile, and utterly inhospitable to any known form of biology. The temperatures in the upper atmosphere plunged to minus 200 degrees Celsius. The pressure would crush any earthly organism in an instant. And yet, as scientists examined the possibility more carefully, they realized they were thinking about life in an anthropocentric way. Life as we know it requires water, carbon, and relatively moderate temperatures. But life as it could exist in other forms might thrive in conditions we consider impossible. Consider the extremophiles discovered on Earth. Organisms that live in boiling hot springs, in the crushing depths of the ocean, in environments so hostile we once thought nothing could survive there. If life could adapt to those conditions, why couldn't it adapt to the conditions inside Uranus? The interior of the planet is actually much warmer than the upper atmosphere. There's liquid, there's energy, there's chemistry. All the ingredients for a kind of life might exist in those dark, pressurized depths. The conversation shifted from planetary science to the search for extraterrestrial intelligence. For decades, humanity had been broadcasting radio signals into space, hoping to contact alien civilizations. We had never received a response. We had searched the skies with radio telescopes, listened to the stars, and heard only silence. And yet perhaps the answer had been there all along, encoded in the electromagnetic emissions of an ice giant, waiting for us to develop the technology and the insight to understand it. Within weeks, cryptographers and mathematicians had joined the research team. They began working around the clock, trying to decode the messages hidden within the patterns. What emerged was staggering. The sequences weren't random, they were deliberate, they were communication. And some researchers swore that certain patterns, when translated and analyzed, seemed to constitute warnings. The latest data suggested that whatever was happening inside Uranus was accelerating towards some kind of climax. The heat output was increasing exponentially. The atmospheric disruptions were becoming more violent. The radiation emissions were building toward a crescendo. Models projected that within months, perhaps less, something catastrophic would occur. Whether it was the complete collapse of the planet's core, a catastrophic release of accumulated energy, or something else entirely, no one could say. But the mathematical patterns buried in Uranus's signals seemed to suggest a countdown, a sequence of numbers that, when decoded, appeared to represent a timeline. And when scientists calculated what that timeline meant, they realized it correlated with astronomical observations made only days before. The messages seemed to have been sent in response to something that had happened recently in our solar system, something that had disturbed Uranus enough to generate these desperate electromagnetic signals. These cries for help or communication launched across billions of kilometers toward a species that had only recently learned to listen. What had Uranus detected that we had not? What event in our solar system had triggered this planetary emergency? Scientists began reviewing every observation, every data point, every piece of astronomical data recorded in the days and weeks before the signals appeared. And there, hidden among the routine observations, they found something, a small anomaly, a gravitational fluctuation that had been noted but dismissed as a sensor error, a momentary disturbance in the fabric of space-time near Uranus's orbital path. Something massive had passed near the ice giant, something that didn't appear in any of our solar system models, something that had come from outside, from the interstellar medium beyond our sun's gravitational influence. And Uranus had detected it. Whatever it was, it had come close enough to disturb Uranus's internal structures, to awaken whatever intelligence or phenomenon existed in its depths, and to trigger this catastrophic cascade of events we were now observing. The implications were profound and terrifying. We were not alone. We had never been alone. And somewhere out there, Beyond our small collection of planets orbiting the sun, something existed, something large enough, massive enough, to shake the foundations of an entire world. And it had just passed through our cosmic neighborhood. No one knew if it was coming back. No one knew if it posed a threat. And no one knew if the messages being transmitted from Uranus were desperate communications sent to warn us, or something far more complex and unknowable. All we knew was that our understanding of the solar system, our place in the cosmos, and the nature of life itself had just been fundamentally altered. The observations continue. The data keeps flowing in. Teams across the world work frantically to decode the messages, to understand what's happening on Uranus, to prepare for whatever comes next. And in the upper levels of government and space agencies, classified meetings discuss contingencies, backup plans, and the possibility that this event represents not an isolated incident, but the first contact with something that has been waiting in the darkness for us to evolve far enough to recognize its existence. Uranus, the planet we once considered boring and forgettable, has become the most important world in our solar system. Its mysteries are our mysteries now. Its fate may very well determine our own. And as we stand on the edge of a new era of cosmic understanding, we're finally beginning to grasp a truth that should have been obvious all along. We live in a universe far stranger, far more complex, and far more alive than we ever dared to imagine. The future of human civilization may very well depend on understanding what's happening on Uranus, and what it means for us all.